What if I told you that the modern skyscrapers of glass and concrete that we are so proud of are, from a historical perspective, nothing more than temporary huts? We are accustomed to thinking of our civilization as the pinnacle of engineering, but our most durable bridges and houses begin to require major repairs just 30 years after construction. Meanwhile, structures in the sands of Giza have withstood rain, wind, and earthquakes for 40 centuries. Modern concrete crumbles, steel reinforcement rusts inside walls, and facades are covered with a network of cracks, while the blocks of the pyramids retain their perfect geometry. The engineers of the past knew secrets that we, in our pursuit of speed and cheapness, have chosen to forget or ignore. They worked with materials as if they were going to live forever and did not compromise on quality. We build quickly and high, but at the same time we lay a destruction timer in the foundation. The difference between their approach and ours lies not in magic or alien technology, but in a fundamental understanding of the properties of stone. Watch the video to the end, and you will learn how ancient builders cheated time and why your concrete wall is doomed to destruction.
Keep going on the left side. Watch out for the...
What if I told you that everything you believed about the strength of reinforced concrete is not true? We are used to thinking that the combination of steel and concrete is a perfect union that ensures the indestructibility of our homes.
This diagram shows the long-term effects of moisture on the rebar.
But we use the specified concrete mix.
It won't matter in 50 years. We're building the risks right now.
However, it is this union that carries the seeds of inevitable destruction for any modern building, something that developers are silent about. Reinforced concrete contains a time bomb that is activated by moisture and time. The ancient Egyptians would never have allowed such a gross engineering error in their eternal monuments. The problem with modern construction is the use of metal reinforcement hidden deep within concrete slabs. Steel has enormous tensile strength, which allows us to build floors covering huge areas. But metal has a tendency to oxidize, turning into loose rust at the slightest contact with moisture. When a steel rod rusts, it increases in volume several times over, pushing the concrete apart from the inside. This creates enormous internal pressure, which inevitably breaks the stone. Egyptian architects used only stone, avoiding the introduction of foreign materials susceptible to corrosion. They understood that any metal, wood, or other organic material inside a wall would sooner or later rot or oxidize. Their structures are made of a homogeneous material that does not conflict with itself on a chemical level. A granite block has nothing inside it that could expand and tear it apart. This is the principle of monolithic integrity, which we have lost in the pursuit of cheapness. In modern walls, the process of destruction begins not on the outside, but deep inside, where it is impossible to notice. Microscopic pores in the concrete allow moisture and air. A chemical reaction triggers a process that engineers call concrete cancer. First, invisible hairline cracks appear, through which even more water penetrates. The cycle accelerates, and after a few decades, the solid wall begins to crumble into pieces. Ancient builders relied on compression rather than tension, so they did not need metal rods. They laid the stones so that gravity pressed them together, making the structure only stronger over time. There is no internal stress in their walls created by conflicting materials. Stone simply rests on stone, remaining at rest for millennia. It is a philosophically different approach, cooperating with physics. I'm very interested to hear your point of view. What do you think about modern technologies deliberately making our homes less durable? Write about it in the comments. Are you ready to learn the truth about why concrete turns to dust? Modern concrete is the product of a complex chemical reaction that requires ideal conditions to complete. However, on modern construction sites, no one waits years for the material to gain its true strength. We use hardening accelerators and chemical additives to remove the formwork after just a few days. This rush results in a structure full of microscopic defects and internal stresses. Egyptian mortar, where it was used, had a completely different nature and composition. Most often, they used mixtures based on gypsum.
Ensure the gypsum fills the seam completely.
Modern cement shrinks slightly in volume as it hardens, contracting and forming a tension network. Gypsum, on the other hand, retains its volume or even expands slightly, tightly filling the voids. This allowed ancient masonry to avoid cracking in the first years after construction. Nowadays, concrete is mixed with a huge amount of water so that it can be easily pumped to a height. Excess water evaporates from the hardening mass, leaving behind billions of empty pores.
Build it high for the Pharaoh's throne.
These voids make the material similar to a solid sponge, ready to absorb moisture from the atmosphere. Egyptian stones carved from rock do not have such a porous structure. Their density is formed by millions of years of geological pressure, not by a rapid reaction in a concrete mixer. Chemical processes in modern concrete can continue for decades, changing its structure for the worse. Under the influence of carbon dioxide from the air, concrete carbonates, reducing its protective properties. The alkaline environment that protects the reinforcement is gradually neutralized, opening the door to rust. Natural stone, such as granite or limestone, is chemically inert and stable. It has already undergone all possible reactions millions of years ago. We often see tiles or plaster falling off building facades after just a couple of seasons. This is the result of incompatible materials that react differently to temperature and humidity. The Egyptians used uniform blocks that expand and contract in the same way. They did not have a problem with flaking because the wall was a single piece, not a layered cake. The absence of unnecessary layers guaranteed reliability. But even the strongest stone is useless if it is laid incorrectly. Want to learn a secret that will change your life and your perception of precision? In the next chapter, you will learn about a technology that makes the joints between stones stronger than the stone itself.
Pull together. Steady now. Steady now. Heave.
What I am about to show you is prohibited in 12 countries as a building standard because of its incredible cost and labor intensity. I am talking about the famous polygonal masonry and block fitting that we see in Egyptian temples. You have probably heard the phrase that you cannot even insert a knife blade between the stones of the pyramids. This is not just a beautiful metaphor for tourists, but a technical fact that ensures monolithicity. The blocks fit together with such precision that there is practically no air between them. Egyptian craftsmen spent an incredible amount of time grinding the contact surfaces of each block. They used copper saws and abrasive sand to achieve a perfectly flat surface. This created an effect that modern physicists would call optical contact. When two perfectly flat stones are placed on top of each other, they begin to work as a single unit. The friction between them becomes so great that it is impossible to move them. In modern construction, we rely on a thick layer of mortar to smooth out the unevenness of bricks or blocks. Mortar is always the weak link. In Egyptian masonry, there is no weak link, only direct contact between materials. The absence of gaps means that water cannot get in, freeze, and break the stone. The uniqueness of their method was that they often processed the joint after installing the adjacent block. It was a process similar to a dentist fitting a filling to the shape of a tooth. Each stone had its own unique place and could not be replaced by another. It was not assembly line work. This density of joints creates an interesting effect of load redistribution within the wall. Pressure from the upper rows is transferred downward evenly across the entire surface, rather than at specific points. In modern brickwork, the load is often concentrated on protruding points, causing cracks. The Egyptian wall works as a single rock mass, where stress is dissipated without harm. It is an engineering marvel achieved only through patience and hard work.
Look at how the weight's distributed. Not a single weak point.
Truly a marvel. Our legacy will stand forever.
If you think precision is the only secret, you are mistaken. Please like this video if you are impressed by the craftsmanship of the ancients. Like this video to
We
support our
match the
channel.
grain perfectly.
Millennia from now, they will know our names.
Guess what's under the base of the Great Pyramid, holding up millions of tons of stone? The answer may seem simple, but it fundamentally distinguishes their approach from ours. The Egyptians never built on loose soil or simple sand, relying on a concrete cushion. They searched for and cleared away the natural rock foundation, the continental plate, which had been established over millions of years. The Pyramid of Cheops stands on a specially leveled rocky plateau. Modern buildings are often constructed on unstable ground, swamps, or embankments. Engineers use piles that are driven deep into the ground to find support. But even the deepest piles can shift, and the soil around them can settle or be washed away by underground water. The settling of a modern house is a norm that we have come to accept. For an Egyptian builder, settling would have been a disaster. Before construction began, ancient engineers did a tremendous job of leveling the rock site.
Move the channel to
They
the
used a
next marker.
system of water
We'll move
channels
it
to
now.
create a perfect horizon across the entire base area.
Look at it. Absolutely precise.
The deviations in the
Strong
level of
base
the
for
Great
the
Pyramid's
eternity.
foundation are only a couple of centimeters over hundreds of meters in length. Such a perfect base ensured that the load from the mountain of stones would be distributed strictly vertically. The slightest skew at the beginning would have led to a collapse at the top. We often see cracks in the foundations of private houses and high-rise buildings caused by soil heaving in winter. Water in the ground freezes, expands, and lifts the house, breaking the concrete strip.
We're looking at major structural instability here because of the freeze-thaw cycle.
It's going to keep happening every winter.
Egyptian rock foundations ignore these processes, as monolithic rock does not absorb water and does not move. They built on the bones of the earth, not on its skin. This ensured the absolute immobility of the structure. Modern foundations are always a battle against nature. Waterproofing, drainage, insulation. We try to protect concrete from the aggressive environment in which we immerse it. The Egyptians chose a location where nature itself would work for them. The desert plateau, far from the Nile floodplain, provided a dry and solid foundation. Geography was the first and most important step in their engineering plan. But what held the stones together if they didn't use cement? Are you ready to learn how gravity replaces glue? Most of Egypt's monumental structures lack what we consider an essential element of a wall: mortar.
Will stand for
This
1,000
technology
years.
is called dry
Truly the
masonry,
work of the gods,
and it is
master.
one of the main
Not even
factors
a
in
knife
durability.
blade can pass the joints.
Mortar in a modern wall is the glue that holds the bricks together. But any glue dries out over time, crumbles, and loses its properties. In an Egyptian wall, the stones are held in place by their own enormous weight.
Look at that fit. Not an ounce of mortar in sight.
When you
to last
use mortar,
generation,
you create a layer
just like
that is
the plant.
chemically and physically different from the base material. Mortar has a different density, different thermal conductivity, and different water absorption. This creates areas of stress at the boundary between materials when heated or cooled. In dry masonry, stone touches stone, and the entire wall reacts to changes in the environment as a single organism. There are no
Tap it in
foreign
on the
elements, no conflict within the wall. The weight of the blocks in Egyptian temples is measured in tens and hundreds of tons. This force is constant and free. It does not weaken over time like cement. The heavier the block, the more securely it sits in place. That is why they strove for gigantism. Size was a guarantee of stability. Modern brick walls are thin and light. They cannot stand without a binding agent. If the mortar is removed, a brick wall will crumble from a slight push. An Egyptian wall, even if shaken, will simply settle more tightly. The blocks may shift slightly, but they will not fall out, as they are held in place by friction and mass. This is the principle of a self-stabilizing system that forgives minor movements. The absence of mortar also solves the problem of capillary moisture absorption. In a brick wall, water can rise up through the pores of the mortar, destroying the wall from the inside. In dense granite masonry without joints, water simply has nowhere to go. The joint is so dense that it does not act as a capillary. In modern seismic zones, we try to reinforce concrete so that it does not crumble. The ancients used a different approach. Want to know how giant puzzles saved temples from earthquakes? What if I told you that pyramids and temples can dance during earthquakes? Egypt is located in a seismically active zone, and ancient builders were well aware of the destructive power of underground tremors. A rigid structure, such as a modern monolithic house, can crack or break under a strong impact. Rigidity is not always strength. Sometimes it is fragility. The blocks in temple walls are often not rectangular, but have complex polygonal shapes. The corners of the stones overlap each other, creating interlocking joints. During an earthquake, such a wall does not crumble, but begins to move at these joints. The blocks rub against each other, dissipating the energy of the shock, but the interlocking joints prevent them from falling out. The wall breathes, dissipating the seismic wave, and then returns to a state of rest. The dry masonry we mentioned earlier plays a key role here. The absence of rigid adhesion with mortar allows the structure to deform slightly without collapsing. Modern concrete cracks when deformed because it is not elastic. An Egyptian column, composed of separate drums, can sway slightly like a stack of coins, but its center of gravity returns it to its place. This is the principle of a roly-poly toy implemented in stone. Sometimes builders use special butterflies or brackets made of wood or metal to fasten the blocks together. But they installed them in grooves so that the stones had a little freedom of movement. In the event of strong tremors, these brackets could take on part of the tensile load, but the main protection was the geometry of the layout and the enormous weight. Light buildings shake more than heavy pyramids, which dampen vibrations with their mass. We build skyscrapers with expensive dampers and floating foundations to withstand the elements. The Egyptians achieved the same effect simply by choosing the right shape for the stones. They did not try to stop the earthquake. They allowed the building to survive it. It's Aikido in architecture. But even if a building can withstand an earthquake, can it withstand the daily assault of sun and wind? In the next chapter, we'll talk about choosing materials. Do you know which stone lasts the longest?
See the fault line right there.
The secret to durability begins long before construction. It begins in the quarry. The Egyptians were masters of geology and knew the properties of different types of stone. For the most important eternal structures, they chose not soft sandstone, which is easy to work with, but the hardest granite, diorite, and basalt. These igneous rocks are born in the fire of volcanoes. Granite blocks absorb virtually no water, making them immune to freeze-thaw cycles, even if the climate changes. They are not affected by windblown sand, which acts as an abrasive. Soft brick or concrete would have been worn down to dust over thousands of years under the impact of sand particles. The granite cladding of the pyramids and temples has only been polished by the desert winds, becoming even smoother. Extracting and processing such hard stone without steel tools was a feat. They used dolerite balls, stones of an even harder rock, which they used to strike the granite for hours to chip off pieces. It was a process of incredible perseverance. A modern builder would choose foam blocks or bricks because they are quick and cheap. The Egyptians chose granite because it is forever. The difficulties of processing were the price of immortality.
Steady now, push it in.
They also used limestone, but only of the highest quality and for specific purposes. For example, the white limestone facing of the pyramids was much denser than that used to build the core. They understood that the skin of a building must be stronger than its interior. Today, we often do the opposite. We cover a sturdy concrete frame with a cheap and fragile ventilated facade. Today, granite is mainly used to finish banks and subways to create an appearance of reliability. For the Egyptians, it was the main construction material. Imagine a modern house built entirely of granite slabs. It would cost billions, but it would last forever. Economics dictates our choice of materials that are doomed to destruction.
Heave. Pull together now. Watch the edge.
Water and wind are the main enemies of any building. Living in the desert, the Egyptians understood perfectly well the destructive power of rare but powerful rainstorms and constant sandstorms. Their architecture was designed to minimize the effects of erosion. The shape of the pyramid is not only a sacred symbol, but also an ideal aerodynamic shape. The wind flows around its edges without creating areas of turbulence that could tear away stones. Modern buildings with flat roofs and protruding balconies are traps for moisture and wind. Corners and joints are where destruction begins. Egyptian temples had powerful cornices and gutters, often decorated with lion heads, which carried rainwater away from the walls. They prevented water from flowing down the masonry and washing away the joints. The absence of small details on the exterior facades also played a role. The Egyptian style is monumental and laconic. The fewer small protrusions, the fewer hooks for erosion. Bas-reliefs and inscriptions were more often made recessed, counter-relief, rather than convex. This protected the image from being worn away by wind and sand. The image was hidden inside the stone, rather than protruding outward. Desert sand is like sandpaper that works 24 hours a day. Modern glass facades become cloudy in such conditions within a couple of years. Egyptian granite, as we have already mentioned, only benefits from such polishing. Builders took into account the direction of prevailing winds and oriented structures to minimize damage. Their approach to erosion was passive resistance. They did not try to stop the wind. They made their buildings streamlined. They did not try to seal the stone. They chose stone that did not need sealing. Size matters when it comes to durability. Egyptian architecture is gigantic not only because of a desire to impress, but also for purely practical reasons. The enormous mass of a structure creates inertia. The larger the object, the more difficult it is for external forces to change its state. Huge, thick walls heat up and cool down slowly. They do not vibrate in the wind, and they are difficult to damage accidentally. Modern construction strives for lightness and openness. We are proud of thin floors and glass walls, but lightness means vulnerability.
Look at this. Another crack already. They just don't make them like they used to, huh?
A thin wall freezes through. A light roof can be torn off by a hurricane. The walls of Egyptian temples could be several meters thick. This created a margin of strength many times greater than the minimum required. Engineers call this the safety factor. In modern design, this factor is calculated economically. Make the structure just strong enough so that it does not fall, plus a small margin. The Egyptians built with a 10-fold or even a 100-fold margin of safety. Their columns could have been 3 times thinner and still supported the roof, but they made them massive for reliability and visual eternity. Massiveness also protects against vandalism and accidental damage. To damage a pyramid, you need modern explosives or years of work with a crowbar. An ordinary person cannot harm it. Modern buildings are fragile. Broken glass, punctured drywall, bent siding. We live in a world of fragile things that require careful handling. Egyptian ruins require nothing. This scale also solved the problem of pressure. By distributing the weight over a huge base area, they reduced the load on each square centimeter of soil. Despite its enormous weight, the pyramid exerts less pressure on the ground than it might seem, thanks to its wide sole. This made it possible to avoid critical subsidence.
Push harder. Move that stone.
Ultimately, the main reason why Egyptian buildings have stood for thousands of years lies not in technology, but in worldview. For the ancient Egyptians, earthly life was only a brief moment, a preparation for eternal life in the afterlife. Houses for the living, palaces and huts, were built of unfired mud bricks because they were temporary. They have long since crumbled to dust. But tombs and temples were homes for eternity, homes for the soul of Ka. They had to stand forever to ensure immortality. Building a temple out of temporary materials would have been blasphemous and senseless. The task dictated the means. The goal was not to build an office for 50 years, but to create a portal to eternity. When the goal is so grand, compromises are impossible. Modern culture is a culture of consumption and disposable items. We change our phones every year, our cars every 5 years, and move to new apartments. We don't need buildings that will last 4,000 years because in 50 years they will be obsolete, unfashionable, or inconvenient. We plan to demolish a building even at the design stage. Egyptian architecture is static. It did not chase fashion. The canon remained unchanged for millennia. They did not need to rebuild temples for new needs because rituals and gods were eternal. The stability of society was reflected in the stability of stone. Our society is changing too fast to be frozen in granite. The paradox is that our technology allows us to build a pyramid in a couple of years using cranes and diamond saws. But we will never do it. We lack the motivation, the ideology that would compel a nation to spend resources on a mountain of stone that is useless from an economic point of view. We can, but we don't want to. They could with difficulty.
Watch the alignment on the southeast corner. Slow down, we're getting interference from the heat haze.
Pull harder, men! Lift!
We have examined the technical and philosophical reasons for the incredible durability of Egyptian buildings. The absence of metal, perfect fit, gravity instead of glue, and the choice of granite are all part of a single system designed to combat time. Ancient builders showed us that true sustainability lies not in the complexity of technology, but in the simplicity and honesty of materials. They did not try to cheat nature with chemistry. They cooperated with physics. Looking at the cracks in our new homes and the smooth walls of the pyramids, it is worth considering. What will we leave behind? Mountains of construction waste and rusty rebar, or something that will inspire awe in future generations, thousands of years from now? History judges civilizations not by their iPhones, but by their ruins. And so far, the score in this competition is clearly not in our favor. What other ancient technologies inspire your admiration and seem lost to us? Suggest topics for future videos in the comments, where we could explore the secrets of Roman concrete or Inca polygonal masonry. And don't forget to subscribe to our channel so you don't miss out on new journeys into the past.